Okay, so now then, I will list some objectives of this course. What I would like to teach you, what I want you to learn from this course. First, there are five objectives, which is listed by the textbook, but I totally agree with that. Um, First, you need to learn methods, how to estimate the causal effects using observational data. That's the maybe the most important knowledge you are going to learn from this course. And second, additionally, in addition to estimation, you would like to learn how to predict. So prediction is a little bit different. It's forecasting, like prediction, and that's a little bit different from causal effects estimation. So you may want to learn that because forecasting and predictions are important in many applications. And three, I want you to understand those methods through applications. Uh, I know that many econometrics courses, statistics courses, are taught too much theoretically. Theory is important. Statistic theories and like mathematics, proofs, theorems, notation, equations, they are important. Of course, they are important, but they are important as means of understanding, right? So I totally agree with this third point. What's you I will try the textbook actually gives a lot of examples, and then you have to imagine yourself as a decision maker or the researcher on that topic. So those examples are very important, obviously important examples. So then, like for example, assume that you need to determine the tax rate, you need to determine the interest rate. Then what you will consider, what's your main goal, what you want to answer. So imagine, put yourself into the position of those decision makers, and that's what you are going to do in your job, right? So later, after you graduate with the economics degree, then your employer expects you to be able to handle those data and get some conclusions, obtain conclusions with, and you should be able to explain the mechanism why it works, why and what's your suggestions, something like that. So train yourself uh, under that situation. And fourth, learn to evaluate the regression analysis of others. So you, of course, the first objective is to make yourself be able to uh, conduct statistical analysis, but also what's as important as yourself doing the analysis is to criticize others. So otherwise, so learning statistics, even if you are not going to use statistics models, but in your life, in your job, in your career, you will, for sure, you will encounter others' statistics analysis. And most of them are biased and misleading or contradict to your goal. You would like to argue this way, but say your opponent brings up data which contradicts your argument. Then you should be able to criticize your opponent's data or statistics result, its interpretations. So learning the statistics is important even if you are not going to use it by yourself. So like even if you don't use statistics in your life, so everyone or someone around you is going to use it. So then you should be able to understand. So that's what your employer expects from you. And finally, so you are going to train that in the problem sets, in the homework assignments. So you are going to use, I will give you example data, and you will use the data and put that into a software and make your own code and get the results and make a table out of the results and interpret that and make it as a report. So that's a simplified process of data analysis job, like what many people hired in many companies are doing these days. So you have to like experiencing those full process will be very valuable in your career. So I believe, and that's what I wanted to say here. And from now on, so the introduction is over. Then the second step is to review the basic statistics and probability concepts. It's chapter 2 and 3 in the textbook. And as I said, the prerequisite for this course is 320. 320 economic statistics is a prerequisite for this. And in my channel, I taught 320 last year, fall 2020. So you should be able to watch those videos if you are willing. If you wanna waste some time, then you may watch them. But I do encourage if you don't remember, if you forgot what you learned there, those concepts are important. I'm going to use them. Here, I will review them very briefly. I'm not going into the details as much as I did in 320. By the way, also another problem is if you have taken 320 from another professor, then frankly, I don't know what was taught and what's the different from mine. So I will assume that you other courses, other sections, other classes covered the same topics, and what I taught is the standard, or is what I expect you to learn. If not, as I said, you can watch my videos to see what I taught in that course, and you may review if you want. So okay, let's think about let's think about an example. The example we are going to reuse this example a lot. So the problem we would like to study is the class size and educational output. What is the relationship, and more carefully, what is the causal relationship between these two? So when you reduce the class size, what is its impact on educational output, right? So what is the effect if you reduce class size by 1 student or by 8 students? Then of course there is no experiment in this, and we have data. Without data we cannot do anything. So let's start from the data. Fortunately, there are nice data. It's from California, and from 420 school districts, from 6th grade to 8th grade. And the variables include 5th grade test scores, and it is standardized test scores averaged by school districts. And also we observe student-teacher ratio. This is a replacement for the class size, a measure of the class size. So how many students a teacher has to handle, right? Quite obvious numbers, you know what they mean. Then, okay, the data are given. Then how can we analyze them? Let's think it one by one. First, we are going to start from the very basic. This table is a summary of the distribution of each variable. Student-teacher ratio has average, standard deviation, and percentiles. In case if you don't remember percentiles, you have to review it by yourself. I taught it, so bottom 10%, bottom 10% school district has student-teacher ratio of 17.3, and top 10% district has 21.9. So there is a variation, and median school district has 19.7. So remember what it means: average, standard deviation, percentiles. You should be able to interpret what they mean and read them. And test scores, average is 654, standard deviation also percentiles. So bottom 10% school district had an average of 630 points, and top 10% school district had 679 points. So it's just a basic summary, and it does not tell anything about the relationship. It's just one by one, variable by variables summary. But still, always the first step to read the data is from this table. You have to see if you see something weird, then you can find the problem here. For example, if standard deviation is too large, too small, or like say certain percentile is too, like say 10 percentile is too low compared to the others, or 90 percentile is too high compared to the others, then you may expect something like outliers or missing variables or some errors in the data. So reading those summary variables, summary statistics is always the first step to analyze the data at any level, at undergraduate level or at like professional data analysts. Also start from this point, this table. So, and you should know this, but you should have learned it from 320. Okay, I'm going to continue from here in the next video.